These examples go with lesson 7.1, confidence intervals for a population mean, standard deviation known. Example 1. Find the critical value z sub alpha over 2 to construct a confidence interval with the given level. A, 90%, B, 98%, C, 99.5%, and D, 80%. Okay, in order to finish this one, we're going to have to pull up table A.3. This is our student's t-distribution. All right, and this can be found in your appendix in your textbook on table A.3. Okay, and this is what it looks like. It kind of looks like our table A2. It's got a lot of values in here, but you'll notice over here on the left we have degrees of freedom, and we'll talk about that after a while. And then up here at the top we've got some percentages, and this is going to be the area in the right tail. And if you can see the picture up here, when we look at the normal curve, we're actually finding the area under the curve that's to the right of our z-score rather than, or actually our t-score, rather than to the left of our z-score like we did in table A2. Okay, to answer the questions in example 1, we're going to go all the way down to what I call the z-line. And I call it the z-line because down here on the bottom, you'll notice that the last thing in the column of degrees of freedom is z, and we've got some numbers, and then directly below that we've got percentages, which would be our confidence level. Now for part A, we were looking for the critical value that goes with 90%. So down here, we're finding 90%, there it is, and the critical value that I want, there it is, it's located 1.645. So for part A, we know we want our answer to be 1.645. Okay, now for B, we're going to do 98%, and I'm going to pull that table A3 back up again. We're going to look down here on the Z line, 98%, there it is, right above it, 2.326. Okay, and right now all we're doing is we're getting practice on reading this table. Okay, if we want to find the 99.5%, we'll come back over here to table A3. Down here on the Z line, 99.5%, there it is. The critical value right above it, 2.807. 2.807, and then the last one, 80%. So let's pull up table A2 again. 80%, here it is, the critical value right above it, 1.282. 1.282. All right, and that is how we find the critical values, or our z sub alpha over 2 values. They're also known as critical values, if you know the percent confidence that you want to have. Example 2. Find the levels of confidence intervals that have the following critical values. For A, we have z sub alpha over 2 equals 1.96. B, we have z sub alpha over 2 equals 2.17. For C, we have z sub alpha over 2 equals 1.28. And for D, we have z sub alpha over 2 equals 3.28. So what we're going to do is kind of the opposite of what we were doing before. We're going to pull up table A.3, and now I'm looking for the percent. How confident am I that this is the critical value? Well, this is the critical value that goes with what percent is what I'm actually going to be doing. So let's pull up table A3. We're going to start off, we're going to be looking for 1.96, and we're going to find out what percent confidence I need to have to use 1.96 for table A3. So we're down here on the Z line. We're looking for 1.96. There's 1.645. There we go, 1.96, and the percent value that goes with that right here is 95%. So if my critical value is 1.96, then I am using a 95% confidence level. Okay, now for B, we're looking for 2.17, and once again, I'm going to be pulling up table A3. We're looking down here across the bottom for 2.17. I go from 1.96 to 2.3 to 2.5. 2.17 is going to fall right here in between 95 and 98. So this time, my critical value didn't actually happen in the chart. So I'm going to have to do a little bit of work to get this to work here. Okay. So what's going on is, right now, we have a Z value, which right now is at 2.17. And I need to know how much area there is back here. Now this is all the way to the left, because what I'm going to do is I'm going to take all of this area and I'm going to shift it over to the right just a little bit, and then that should be able to tell me what percent of the area is actually underneath this curve when I have the same amount of open space over here that I have over here. And so we're looking at the area under the curve right here. So this is what I'm looking for. Okay. All right. And this is what I have to work with. Well, this is a Z-score. And if I pull up table A2, I can figure out exactly how much area there is underneath that curve there. So let's look at table A2. Now my Z-score is at 2.17. Here's 2.1. 0, 1, 2, 3, 4, 5, 6, 7. And I see that the area under the curve is 0.9850. Okay, so that means that the area back here is 1 minus that. And 1 minus 0.9850 is going to give me 0.0150. Okay, so remember what I said I wanted to do with this area? I want to split it so I have the same amount over here that I have over here. So I'm actually going to shift all that area a little bit to the right so that I have open space back here and I have open space back here. The question is, how much area is inside here and here? Well, if I have this much and I want to put exactly half of it in both places, I'm actually just going to take the 0.015 and I'm going to divide that by 2. And that's going to give me 0.0. Hang on. Okay. So again, what I want to do is I want to take my curve and I want to shift it over to the right just a little bit. Well, I'm not even going to shift it over to the right because I know I want this number here to be 2.17 and all this back here to be open space 0.015. All right. And right now, what I have is that all of this area in here is 0.985. Okay. Well, what I would like to do is I would like to create something that looks kind of like this, where I have the same amount of open space back here that I have back here, and then all of my area is actually shaded in the middle here. Now, this is a set number. We're using 2.17, and I have the area back here in the white part as 0.0150. So what I'm going to do is I'm going to take some of this area off back here, And what I'm actually going to be taking off is 0.0150. So there is a number right here, so that the area of it to the left is 0.0150. And now I've got all my area contained in the middle here. Now remember, what we're trying to do is we're trying to find an interval. Well, I have an interval. My interval goes from here to here, and I'm hoping that whenever I'm trying to find a statistic or a parameter, it's going to be located between these two values. Now this conveniently is going to be the z-score negative 2.17, and we get that because our normal curve is symmetric there. Okay, now I didn't ask you for that, but that is what that one right there is going to be. Okay, so now that I have taken this piece of area away right here, now we're stuck with trying to figure out, well, what is the value z sub alpha over 2 for the z-score 2.17? And that value is, it's the z-score, or the area to the left of the z-score, 0.985, minus the area that we erased there, so that we could have symmetry on both sides here and have the same amount of area unshaded. And that's going to give me 0.97 or 97%. Okay, for C, we have z sub alpha over 2. This is 1.28. And once again, we can pull up table A3 and look down there along the z line. And there we go, 1.282. And that looks like that one's going to go with 80%. All right, and then our last one, z sub alpha over 2, 3.28. So let's pull up that table A3. All right, and that's going to be, now the last one here is 3.29, and then I have 3.09. So it's somewhere between 99.8 and 99.9. So we're going to have to do the same trick here that we did for part B. Okay. I think we're going to need to make a little bit of room. Oh, no, I think we got it. Okay. Okay, so right now, I have a curve that looks kind of like this, and my z-score is way back here at 3.28. And I'm getting ready to find all of this area back here using table A2. 3.20, 1, 2, 3, 4, 5, 6, 7, 8. So it's 0.9995. 0.9995. That means that my open area back here is 1 minus 0.9995. And that's going to give me 0.0005. Okay, now remember, I'm trying to create symmetry here, and I've got open space, so I'm going to create some open space on this side over here. We're going to take off some of this. And there is a point right here, so that the area included here is 0.0005. And so the question is, well, how much area do we have left in here? And the answer is, it's my original area, which was 0.9995, minus this part that I just now opened up, the 0.0005, and that's going to give me 0.999 or 99.9%. So that's one way you can find the critical value if it doesn't show up on the z line of your table A3. Example 3. Find the margin of error given the standard error and the confidence level. All right, the margin of error is just our standard error times our critical value. Now, the critical value is going to come off of table A3, and that's going to depend on what our confidence level is. In this case, our percentages. Okay, so for part A, we have a standard error of 1.2 and a confidence level of 95%. Okay, well, on table A3, let's see if we can find the critical value that goes with 95%. All right, so on table A3, down here on the Z line, we're at 95%, and the critical value is 1.960. That means that the margin of error, or MO, is going to be our standard error 1.2 times the critical value we just found, 1.960. And y'all, we usually round these to 4 decimal places. So let's see, we're going to have 1.2 times 1.960, and this is going to give me 2.352. 2.352. All right, part B, the standard error is 0.4. Our confidence level is 99%. Let's pull up table A3. We're going to look down here on the Z line. 99%, right there it is. The critical value, 2.576. That means that the margin of error is going to be 0.4 times 2.576. All right, let's see what that gives us. And this is going to be 1.0304. Part C, the standard error is 3.5, the confidence level is 90%. Let's pull up table A3. Look down on the Z line here at 90%. There it is, 90%. Our critical value right above it, 1.645. 1.645. So our margin of error is going to be 3.5 times 1.645. Let's see what that gives us. And that gives me 5.7575. All right, the last one, D, the standard error 2.75. The confidence level is 98%. Let's pull up table A3. We're going to look at the bottom on the Z line at 98%. There's 98%. Right above it, 2.326 will be our critical value. 2.326. The margin of error on this problem will be 2.75 times 2.326. That will give us 6.3965. All right, so the margin of error is actually going to help us figure out what our endpoints are going to be on our confidence level, because the margin of error, well, is just kind of what it sounds like. It's an error. It gives us some space to the right of where we think that the actual value occurs, and some space to the left of where we think that the actual value occurs. And that's where we're going to get our confidence interval from. So the question is, what am I going to add and subtract my margin of error to in order to figure out what my confidence interval is going to be? Example 4. An IQ test was given to a simple random sample of 75 students at a certain college. The sample mean score was 105.2. Scores on this test are known to have a standard deviation sigma equal to 10. It is desired to construct a 90% confidence interval for the mean IQ score of students at this college. Okay, for part A, we're supposed to figure out what the point estimate is. Now, in this particular sample, the mean was 105.2, and the actual mean for the entire college is probably not 105.2, but we would like to find an interval that contains the actual mean for the college. So we won't be actually finding the mean, the mu, for the entire population of the college, but we're going to find an interval that's pretty acceptable based on the information that we have right here. And we can be pretty sure, in this case, we'll be 90% sure that the mean for the actual population for the college itself is going to fall between two particular numbers. Okay, and it's going to involve this 105.2 here. Okay, so our point estimate is going to be our sample mean, which in this case is the 105.2. All right, B, we're looking for the critical value. Now remember, the critical value is going to come off of table A3, and it's based on what percent. How confident do we want to be? And we already said we want to be 90% confident. So I'm going to go find the critical value on table A3 that goes with a 90% confidence. So let's pull up table A3. 90% confidence down here, the critical value right above it, 1.645. All right, and now we want to find the standard error. Our standard error formula is going to be the standard deviation for the population divided by the square root of our sample size. Now in our case, we're going to have 10 divided by the square root of 75, because our sample size is 75 and 10 was our standard deviation. Okay, let's see what that's going to give us. And that's going to give me 1.1547. And there's actually some more back there behind. There's like a 00, but I told you we usually round these off to 4 decimal places, so I'm just going to stick with that. All right, part D, we're looking for the margin of error. Now, we already said the formula for the margin of error, or MO, was just to take our standard error and multiply it by the critical value. Now, our standard error we just found, here it is, 1.1547. And the critical value came out of table A3, that's the 1.645. The margin of error is going to be 1.645 times 1.1547. We'll multiply those together. And this is going to give me 1.8995. All right, and then E is asking us, okay, what is the confidence interval? Well, the confidence interval, this is our point estimate plus the margin of error, and it's our point estimate minus the margin of error. And then we usually write them in parentheses as an ordered pair. So it kind of looks like something you would graph on the graph paper there. But we usually write our confidence interval like this, and we'll put some sort of a number over here and then the other end of it over here. And we go from low to high. So this would be the lower of these two numbers, and this would be the higher of these two numbers, because we always put the lower there on the left. Okay, so let's see what we get. Our point estimate we said was 105.2. And remember, I'm supposed to add the margin of error, and I'm supposed to subtract the margin of error to get to my confidence interval here. So let's see. 105.2 minus 1.8995. This is going to give me 103.3005. And then the other one is going to give me 107.0995. Now, since the original point estimate was rounded off to 1 decimal place here, now when I go to write my confidence interval, I'm going to round these to 1 decimal place. That's going to take me from 103.3 to 107.1, because that 9 is going to round that 0 up to a 1 there. And there is my confidence interval. All right, now for part F, now we're going to answer a question based on this confidence interval. Is it likely that the population mean mu is greater than 100? Well, let's take a look at this. Our confidence interval goes from 103 to 107. 100 is definitely not within here. 100 is actually back here on this end. It's to the left of my smallest value. And since I am 90% certain, that's what this is right here, that the actual mean falls in between here, and all of these numbers are more than 100, we can say, yeah, it is likely that the actual mean for the college is greater than 100, because we're 90% certain that the actual mean falls between these two values. So yes, we are 90% certain that the population mean is between 103.3 and 107.1. Example 5. The lifetime of a certain type of battery is known to be normally distributed with a standard deviation sigma equal to 20 hours. A sample of 50 batteries had a mean lifetime of 120.1 hours. It is desired to construct a 95% confidence interval for the mean lifetime for this type of battery. Okay, let's see, look at the things that we know here. We've got our sigma right here. The sample size, that's n. There we go. Okay, mean. This is going to be our point estimate. All right, and our confidence level right there. So I think that gives us everything that we need. All right, question A, what is the point estimate? Well, that's the mean for our sample here, which is 120.1. Question B, find the critical value. The critical value is going to come out of table A3, and that all depends on what percent confident we want to be that the mean falls within our interval. And we want to be 95% confident. So let's pull up table A3. Down here on the Z line, 95%, there it is, the critical value right above it, 1.960. The standard error, remember our formula for the standard error we said on the previous slide was going to be the standard deviation divided by the square root of n. So in our case, that's going to be 20 divided by the square root of 50. Let's see what that gives us. Right, and I am looking at 2.8284. Part D, find the margin of error. Our margin of error formula was just to multiply our standard error, whatever it happens to be, times the critical value. Well, the critical value we found in Part B, the standard error we found in Part C, so the margin of error is going to be 2.8284 times 1.960. We'll round that to 4 decimal places. And this is giving me 5.5437. All right, our confidence interval. Well, we said our confidence interval is just going to be our point estimate minus the margin of error. And then we need to find our point estimate plus the margin of error. And then remember, once we have these numbers, we put them in the parentheses there, and we list our confidence interval that way. Okay, so let's see our confidence interval. Our point estimate, 120.1, minus the margin of error, 5.5437, plus the margin of error, 5.5437. Okay. This is going to give me 114.5563. And then this one's going to give me 125.6437. All right, and my original was rounded off to 1 decimal place, so I am going to round my confidence interval to 1 decimal place. So we're going to have 114.6, and over here we're going to have 125.6, because that 4 does not round that 6 up to a 7. It is going to stay a 6. All right, question F here. Is it likely that the population mean is greater than 130? In our confidence interval, we go from 114.6 to 125.6. So 130 is not even included in here. In fact, it's somewhere back here to the right of my largest number in my confidence interval. And we are right here, 95% confident that the actual mean is going to be in between these two values right here. So it is not likely that the actual mean is 130. No, we are 95% confident that the population mean is between 114.6 and 125.6. Example 6. In a survey of a simple random sample of students at a certain college, the sample mean time per week spent watching television was 18.3 hours, and the margin of error for a 95% confidence interval was 1.2 hours. Part A, true or false? A 95% confidence interval for the mean number of hours per week spent watching television by students at this college is 17.1 is less than mu is less than 19.5. This statement is actually true. And we know this because right here, this is our confidence level. And they went ahead and figured out what the margin of error was right here. And of course, this one is going to be our point estimate. So since we have a point estimate and we have our margin of error, remember our confidence interval is our point estimate minus the margin of error, and then our point estimate plus the margin of error. So let's see, our point estimate 18.3, if we subtract the margin of error, which they said was 1.2, that is going to give me 17.1, which is the number that I have over here on the left-hand side. And if I take the point estimate 18.3 and I add the margin of error 1.2, this is going to give me 19.5, which is the number I have right here on the right. So this is just a fancy way of saying the confidence interval 17.1 to 19.5, and that is certainly true. Part B, approximately 95% of the students at this university watch between 17.1 and 19.5 hours of television per week. Again, is this true or false? This statement is actually false. And at first glance, it looks like it ought to be true because we made a 95% confidence interval. But what does that 95% measure? It doesn't measure the amount of students at the school who are watching the television. It's measuring how sure or how confident we are that whatever the mean is, it's going to fall in between these two values right here. So this 95% has absolutely nothing to do with the student population, and it has everything to do with how sure we are that the true mean actually falls between those two numbers right there. Example 7 is asking us to go back to example 4 and make another confidence interval that's 95% this time instead of 90% like we did last time. So up here at the top, I just reminded you of some of the information we knew. There were 75 students included, and the sample mean was 105.2, and then the standard deviation was going to be 10. Okay, let's go through the same steps that we had to go through in example 4 to get this 95% confidence interval. The first thing it asked me for was the point estimate, and the point estimate is the sample mean, which they gave me to be 105.2. The next thing I was asked for was my critical value. Now my critical value is all dependent on what percent confident I want to be. Now in this case we want to be 95% confident. So let's pull up table A3. Looking down here on the Z line, 95% confident, right above it gives me 1.960 as my critical value. 1.960. The standard error, we already calculated that on the other slide, but I'm going to do it again because remember that's going to be the standard deviation 10 divided by the square root of our sample size here, which is 75, and that's going to give us 1.1547. Remember I had rounded that off. The next thing it asked us for was the margin of error, And our formula for the margin of error was to multiply the critical value times the standard error. That's going to give me 1.960 times 1.1547. This is going to give me 2.2632. Okay. And finally, I want my confidence interval. In the confidence interval, we were supposed to take our point estimate 105.2 and subtract the margin of error, 2.2637. And then on the other end, we're going to take our margin of error, our point estimate, and add the margin of error, 2.2637. All right, let's see what this is going to give me. So we got 105.2 minus 2.2632. And this is going to give me 102.9368. And 105.2 plus 2.2632 is going to give me 107.4632. And since our point estimate was rounded off to 1 decimal, remember we're going to round these off to 1 decimal. This is going to give me 102.9. And this one's going to give me 107.5, because that 6 right there is going to round that 4 up to a 5. And this 3 does not round the 9 up.